All right, let's talk about the next part of these notes, which is going to go into derived units. This slide mentions some of the benefits of the metric system. Of course, it uses the decimal system. Everything's in powers of 10. That's nice. It's an international standard, which is also helpful. But one of the cool things about the SI system is that the units can relate to each other using water as a standard. So one of the ways that units relate to each other is by this process of unit derivation. And the first example we'll talk about is volume. You might have noticed volume was kind of conspicuously absent from the list of base units. And that's because it's a derived unit. In other words, we can build volume from distance. A liter is the unit for volume, and it's defined as 10 by 10 by 10 centimeters. So this is a little teaching tool that shows a 10 centimeter cube, 10 by 10 by 10. And that's a liter. Of course, a liter is a volume like this is a 1 liter beaker, and it's about the size of like the kind of Nalgene you might take to the gym. But a liter is defined in terms of distance units. So we're going to write down a few things in our notes, starting with the fact that this is a derived unit, and that means it's built from other units. And the first example of a derived unit we're going to talk about is volume. Volume is measured, of course, in liters, and 1 liter, the symbol for liter is an uppercase L, is 10 by 10 by 10 centimeters. So 10 centimeters by 10 centimeters by 10 centimeters. Of course, 10 times 10 times 10 is 1,000. But centimeters times centimeters times centimeters is not centimeters, it's centimeters cubed. So a liter is 1,000 cubic centimeters. And that is equal to 1,000 milliliters, since a liter is 1,000 milliliters, right? Milli means thousandth. So it's this relationship that I want to emphasize, the one between cubic centimeters and milliliters, and we're going to summarize it by writing that 1 cubic centimeter is 1 milliliter. So that's how units of distance can be related to units of volume. This is also known as 1 cc, short for cubic centimeter. Sometimes we hear people talk about cc's of volume. Notice that we are talking about a cubic distance, and that brings to mind how volume can be calculated. When you are measuring a liquid directly, you might just pour it into a cylinder, but volume calculations come up when you're trying to get the volume of a regularly shaped object. So let's talk a little bit about the geometry that's involved here, and write just a few more things in our notes about the derived unit of volume. If you are measuring the volume of a cube or a rectangular prism, for instance, you need to calculate it by doing length times width times height. And of course, that's 3 dimensions, right? Distance times distance times distance. If it were something like a cylinder, then you would need to get the area of the circle and then multiply by the 3rd dimension, its height. The area of a circle is pi r squared. And then you would multiply by height or length of the cylinder. And if it were something like a sphere, which I'll just try to make look a little bit more spherical there, that would be 4/3 pi r cubed. So notice in each of these cases, we have a distance cubed, distance by distance by distance, or here, distance squared by distance, and so on. So we're always going to get, if we're measuring our distances in centimeters, of volume in milliliters. So those are all examples of volumes that can be calculated, as opposed to the volume of a liquid, which would be measured directly. So let's take a break there.